All right, here we go. So we are in Unit 6, Lesson 4. This is the big one. Special triangles, exact values, and unit circle. Special triangles isn't technically in the curriculum, if you will, but special triangles helps you understand unit circle. And the biggest complaint from Mr. Moore in Math 30 is that his students don't know unit circle very well. So hoping last semester we didn't get to it because we ran out of time. So I wanted to promise him that I'd get it for you guys so that you guys be better in Math 30 next year. So this is important in terms of building blocks of Math 30. Because when you go into unit circle for, hold on here just a second. No. When you go into unit circle for, when you go to Math 30, you're going to start with trigonometry is what I'm trying to say. So just keep that in mind. My thing's not working. Well, okay. There we go. Okay. All right, so first one we're going to look at is we're going to look at the 45-degree triangle. Okay, and we got to kind of understand something that kind of makes sense. A 45-degree triangle, so 45-90, this side has to be 45 as well. Okay, and that relationship is going to make the two legs the same. Because if 45 degrees makes 1, then 45 degrees makes 1. They have the same angle, they make the same side. Does that make sense? Okay, so determine the length of the hypotenuse. So the legs are 1 squared plus 1 squared equals r squared. So we're going to call that r, radius. That's going to be r squared equals 2. So r equals square root 2. Okay, so we know that to us, this side right here is square root 2. So now from that angle that they gave us, sine 45, they want us to do sine. So remember, it's your SOHCAHTOA, opposite over hypotenuse. So opposite of this 45 is 1, hypotenuse is root 2. This is 1 over root 2. Cosine of 45 is adjacent here over hypotenuse, root 2. And tangent 45 is 1 over 1, which is 1. Okay. Really quickly here, we don't want radicals in the bottom, so we're going to change that. So we're going to go ahead and rationalize the denominator, and we're going to do root 2 to top and bottom. It's going to be the same thing for both of them. So you're going to get root 2 over 2. Okay, and those will be very familiar to you as we get going further here. So that was for the 45-degree angle. Questions so far? Okay, so it's funny, it kind of does it for a second. Diagram 2, we're looking at the 60-degree. So what they did was they made an equilateral triangle from the center, and they made a 60-degree, so that makes this 30, 30, and 60, because all of them are 60 in reality. Okay, and it says that it's an equilateral triangle that everything's 2, and that this altitude, an altitude of an equilateral triangle splits it in half, so that makes this 1 and 1. So it says determine the length of the altitude. So now we can go ahead and use our Pythagorean theorem to figure out the length of the altitude. So we know that 2 squared, because this is my hypotenuse here, right there, that's my hypotenuse. 2 squared equals 1 squared plus a squared. A squared for altitude, or a plus b, whatever you want to call it. So I get 4 equals 1 plus a squared. I get a squared equals 3. I get a equals root 3. So the altitude is root 3. Okay, so now we're going to again go to our SOHCAHTOA, and we're going to finish out sine of 60. Sine of 60 is root 3 over 2. Opposite over hypotenuse. Cosine of 60 is 1 over 2. And tangent of 60 is root 3 over 1, which is just root 3. Okay, and right now, again, get used to these patterns of the root 3 over 2, the root 2 over 2, and the 1/2. If you can get that down, the unit circle is going to be a breeze for you. Okay, so get used to these patterns. All right. Okay, and the last one, we're going to do one with an angle of 30. So we're going to kind of flip our equilateral triangle, and we're going to make it 30 here. So that makes it 30 down here. It's still equilateral. Okay, that makes this 1. That makes this 1 because the whole thing's 2. Okay, and then again, if we do our Pythagorean theorem, we're going to get this length right here, this altitude, since it's tipped down, is going to be root 3 again. So it's the same thing, just flipped, which it is. So it's still a 30, 60, 90 triangle. Okay, so if we go look, this sine of 30 is going to be 1 over 2. Cosine of 30 is root 3 over 2. And tangent of 30 is 1 over root 3, which we are going to go ahead and rationalize that to making it root 3 over 3. We never want radicals in the bottoms for this or anything. Okay, and that's going to help us fill out our charts. Okay, and then the next little bit, I'm going to try to give you a quick thing on special triangles. If you get it, great. If you don't quite get it, it's not the end of the world. You can always do special triangles by Pythagorean theorem, but they all have a pattern. That's why they're called special triangles. These triangles are your 45, 45, and your 30, 60. That's the two types of special triangles. Okay, our last two examples, those were both 30, 60s, but we just did one from the view of 30 and one from the view of 60. So they still were the same triangle, just essentially turned. Okay? Say that one more time. Sorry. Your opposite and your adjacent. Yeah. No, you wouldn't have to. No. And this is just to get the pattern, Nick, in terms of the root 3 over 2, those values I was telling you. So just give me one more second. I think this might explain what you're asking. Okay, so right here is the pattern. Okay, and when I say pattern, if away from the 30, every time away from the 30, it's a 1. Excuse me. And see, away from this 30, it's a 1. Away from the 90, it's 2. Away from the 90, it's 2. No, this is 60 here. Away from the 60, it's root 3. Away from the 60, it's root 3. So it's that pattern for all of them. And I like to explain this with variables. So this may help you, it may hurt you. Okay? I want you to picture that 1 as a 1x. So if that's 1x, then this side is 2x. Okay, it's double. And then this side is x root 3 is the pattern. Okay, so let me just draw a quick example here. If I said this was 30, this was 60, and I told you this was 4. If you had one side, you could figure it all out. Pythagorean theorem, you need what? You need at least two sides. But in special triangles, if you're given one side, you can figure the rest of them out. Because if 30 is 4, remember that's my x side. Okay? So then what is my hypotenuse going to be? 8. 2 times x. So this is going to be 8. And then what's this side going to be? 4 root 3. That's the pattern every time. Okay? So the number, 1, 1. Okay? Times it by 2. Or 1, because there's a 1 here, 1 root 3. So it's a number with a root 3 on it. That's the pattern for special triangles. So the way I explained it, and this is when I was in the States, is I would explain it as x, 2x, x root 3 is your pattern. Figure out what your x is, and everything else is good. So if I went ahead, since you guys are my advanced group, right? Okay, if I give you that as 12, well, what's x? 6. So you could work backwards, 6, 6 root 3, and you'd be done. Okay, that's the pattern of special triangles. Okay, all right, I kind of told you about this one time. The 45, 45 is a little bit easier because we know that these have to be the same. 1 and 1. Okay, the only thing that changes is it's a 1 root 2 there. So now if I said this was, let's change this to 12 and 12, then this side would be 12 root 2. That's how easy the 45 is. It's same, that number, root 2. Okay, that number, root 2. We're not going to get in that. There's some other algebra stuff you can do with that that makes it a little more difficult, but that's the basis. Is there any questions on those patterns there? Okay, and you'll notice that, again, the 30, 60, 90 pattern is the same, it's just turned. They're the same triangle, it's just turned. So if I put, 6 here, then it'd be 12, 6 root 3. Okay, that's all you'd have to do there. All right, so then what they do is, if we consider similar triangles to the above, all the hypotenuse lengths of one unit will get the following triangle. So what they did was they said, okay, if this is 1, now work backwards and figure out what that would be. So remember, this is 2x, right? That's my double. Divide that by 2. So divide this by 2 will give me that one, 1/2. That's how I got the 1/2. 1/2 root 3 went here. That's the same thing as root 3 over 2. That's the relationship. Okay, same thing here. They put a 1 here. Well, that was supposed to be something root 2, so it's going to be root 2 over 2. Okay, and then the other side is the same thing as the first one, it's just flipped. All right, so staying with me here. All right, so the triangles above are similar. The ones in the investigation illustrate the trigonomic ratios to exact values for angles 30, 45, and 60. In each diagram, the horizontal distance is x, the vertical distance is y, hypotenuse r, the radius is 1. So let's complete the following table. So from the examples we just did, for sine x of 30, we got 1/2. We got root 2 over 2. And we got root 3 over 2. For cosine x, we got root 3 over 2. Okay, we got root 2 over 2. And we got 1/2. Okay, and then for tan x, we got root 3 over 3. We got 1. And we got root 3. What's that? Yeah, there'll be unit circles. Knowing the unit circle will help you with stuff on your final, yes. Okay. Consider the rotation angle of 0 degrees. So remember, we're starting at the standard position. So we're starting right here. Okay, on our x-y axis. Let's do this way here. We're starting at that spot there, 0 degrees. In this case, x equals 1 and y equals 0. Why is that? Because this spot on my XY grid is the 1-0, because they said our R is 1. Okay, so what that means is I want you to understand this. These 4 points are kind of like anchor points. This is 0, 1. This is -1, 0. And this is 0, -1. Just like that. Okay, so at sine for 0 degrees, what is sine 0 degrees? What is sine? Go back to our couple lessons ago. What is it? Y over R. So y over R, so that equals, in this case, 0 over 1, which is 0. Cosine x over R. X over R is 1 over 1, which equals 1. Tangent is y over x, which is 0 over 1, which equals 0. Okay, now we're going to turn up to sine. We're going to go up here of 90 degrees. Okay, that's where the 90 is at the top. So now they're going to change our values to x is 0 there, y is 1, r is 1. Okay, so sine would be, again, y over r. So that's going to be 1 over 1, which is 1. Cosine's x over r, 0 over 1 equals 0. And then the last one, we're going to get y over x, which is 1 over 0, which is undefined. Whenever we see divide by 0, that's non-permissible, right? It's undefined. So tangent's not defined at 90 degrees. Okay. All right, and then we're going to kind of make our full chart here that says to memorize, which I'll kind of show you. You're not really going to have to memorize it. It'll be kind of easy. Okay. So this is what we're going to use to make our unit circle with. Okay, so we're going to fill this chart out here. Is we're just going to go through the stuff we already put in. So we already have the sine of 0. We already have these. We already have 0 degrees. Excuse me. 0 degrees for sine was 0. Cosine was 1. For tangent was 0. Okay, if we go back to our 30 degrees, okay, we got sine. We did that earlier in our earlier investigation. We got 1/2. We got root 3 over 2. And we got root 3 over 3. I think that was our first example. 45, root 2 over 2, root 2 over 2. Remember, these will be the same. This over this is the same thing over the same thing as 1 for tangent. 60 is root 3. And then 90, 1, 0, undefined. Okay, I want you to notice something here. If you look, these are our anchor points, 90 and 0. So they're the ones that kind of have whole numbers. The other three are the spots in between. These are the spots in between. Okay, we'll notice that the 45 is simple. It's simple because it's the same over the same because the 45 degrees. It's root 2 over 2, root 2 over 2. Okay, and the 30 and 60, let's see here, I'm running out of colors. The 30 and 60 are the same but flipped, and I'll explain why those are flipped. So in terms of memorizing the unit circle, you don't have to memorize it if you understand the pattern. The pattern actually makes sense, and we'll get that in a second. Okay, real quick here, before we do that, I want you guys to note something here on the side. I want you to note that 1/2, we're going to do this again, is 0.5. Okay, what is root 2 divided by 2? I know root 3 divided by 2 is 0.86. Can somebody give me root 2 divided by 2? Is that what it is, 0.70? Okay, 0.70. Okay, so from biggest to smallest, all I want you to understand is that 1/2 is the smallest, root 3 over 2 is the biggest. Okay, that'll play a part here in my explanation of how to make the unit circle. Okay, all right. Let's get to this first set of examples here. All right, so what this says is, write the following terms of a reference angle, determine the exact value. So we still want to go back to reference angles because what happens with the unit circle is it's all about reference angles. So what I mean by that is, and again, it's going to come further, but I'm going to give you a quick little start. Unit circle is cut into 1, 2, 3 triangles, 30, 45, 60. And it does that for every section. So that means you have the same thing all 4 quadrants. Okay? But those are also reference angles to us. All reference angles are under 90. So if I think about 210, 210 to us is right here. That's a reference angle of 30. So that's going to be my 30 triangle. Okay? So we're thinking sine of 30 degrees. Okay? The only thing I have to think about is in quadrant 3 is sine, which remember, sine goes with x or y. What does sine go with? X or y? Y. Okay? So sine goes with y, cosine goes with x. Just keep that in mind too, but we are in negative territory for y down here. So it's going to be a negative answer. So if you look at your sine 30 on your chart we just did, you would have 1/2. You'd make that a negative 1/2 because we're in the negative territory. You guys follow me? Kind of? Okay. Let's do another little picture here. So cosine of 300, we know that's going to be right here with a reference angle of 60. So I'll look for cosine of 60. Remember, this is my CAST, my cast. So C is positive here. So we know that cosine is going to be positive. Cosine of 60, look at my chart. Cosine of 60 is 1/2. It's positive 1/2 and it stays positive. Tangent's the one's a little bit more difficult because you have to do sine over cosine to get tangent. Or y over x. What's that? Yeah, you can use chart from above. Yeah, once you get the reference angle. Okay, 225. So 225 is right here. 225 is a reference angle of 45. Okay, so we want to look at tangent of 45. Tangent of 45 is 1. Okay, but it's in quadrant 3. Tangent in quadrant 3, is that positive or negative? Positive. That's my t, my CAST, right? So this is going to be positive 1, so your answer is just 1. All right, a couple more example here, and then we'll get into the actual construction of the unit circle. All right, example 2. Without using technology, determine the exact values of theta where cosine theta is negative root 3 over 2. So what I want to think about right now is I'm trying to figure out, okay, cosine's negative in these two quadrants, in 2 and 3. The other two, it's positive. And that makes sense, because cosine goes with x, right? All x values over here are positive. All x values over here are negative. That's why it's negative over here. Okay? So now I want to think about, all right, so where is cosine negative root 3 over 2? So if we go back to our chart, it's at 30, right? So that means I want two reference angles of 30 here. These two spots here and here. Because those work for negative cosine being negative root 3 over 2. So we're pretty much done. 180 minus 30, 150 is an answer. 30 plus 180 is 210 is an answer. These are your two answers that give you negative root 3 over 2 for cosine. So what that means is, if you did this in your calculator right now, if you put cosine of 150 and you put cosine of 210 into your calculator, it would give you negative 0.866 or whatever, negative 0.86, both of them, in your calculator. Okay, part B, tangent theta is undefined. Well, we know about undefined. We did a little undefined section. So if I look back at my chart, undefined happened at 90 degrees. And that's the only place it happened. So this tangent theta equals undefined. That means theta is 90 degrees. It's that simple. Okay. Now, 90 degrees is part of it because if I think about my unit circle, up here it's 0, 1, right? Down here it's 0, negative 1. So tangent's undefined at 90 and what? 270. 270 because this one would be negative 1 over 0. That's what this would be. That's also undefined. So 90 and 270 would be your two spots that's undefined for tangent. All right. Okay, if you got questions, speak up. I'm going a little faster. All right. The point negative 3 root 3 is on the terminal arm of angle theta. Without using technology, complete the following questions. Draw the angle and stay in position and mark the point P on the terminal arm. So what I want to do first is I want to make a little XY grid. And I want to plot negative 3 root 3. 1, 2, 3, 1, 2, 3. Root 3 is a little bigger than 1. So I want it to be right about here. So I'm going to draw here's my terminal arm in standard position. Okay. Let's go ahead and label the point. There's my point. Okay, from that picture, we can conclude that x equals negative 3, y equals root 3. Okay, and it says state the values of x and y, hence the values of tan theta. So here's my x and y value, so it wants us to make tan theta. Well, tan theta is y over x. So root 3 over negative 3. Okay, so now, go back to your chart. Do you have a root 3 over 3 somewhere for tangent? You do, on 30 degrees. Okay, now, be real careful here. What quadrant are we in? We're in the second. So if I get 30 degrees, that means this reference angle is 30 degrees. So then what is that rotation angle? 150. 180 minus 30, 150 degrees is what tangent theta is. If I'm losing you, I got that from our chart. Chart at 30 degrees. Okay, and then I figured out, we know from our picture that we're in quadrant 2, so we know that reference angle starts from that terminal arm to 30 right there. All right, now let's get into the actual building blocks of the unit circle here. Okay, so I'm going to fill this out right here. All right, so let's fill out the easy ones first. We know that this is 1, 0, this is 0, 1. Okay, and what I was telling you is these lengths here, from biggest to smallest, we know our numbers are like that. It's talking about heights and lengths of the triangle. Okay, now if we go back to our chart, we can go ahead and we can label these, but I'm going to explain kind of how to understand it. We know the 45 is the easy one. Okay, and then we know this is going to be the other half. Okay, so if we continued our unit circle over here, so I'm going to do just the dots. So we have this dot, we'll go here, here, and we'll sneak one right here. Okay, so that's the other side. Now, what is bigger, root 3 over 2 or 1/2? Just in terms of numbers we talked about. No, the root 3 over 2 is 0.86, right? Now, pay attention. Is the root 3 over 2, is that my x value or y value? X. So, the reason this makes sense, if you're doing the unit circle, is that here's a center, right? What's the bigger width? Or excuse me, what's the bigger length? The width or the height of this triangle? The width is. So it has to be the bigger number. Okay? And then when you think about this guy, where they flip, see now the height is bigger. See now the height is bigger, and the width is smaller. So when you're trying to figure out if you're confused, the only ones that people confuse in the unit circle is it 1/2 or root 3 over 2? Think, is my x bigger or my y bigger? Okay, so what I'm saying is, if I drew this one, what's bigger, my height or my width? My height. So that means I should have root 3 over 2 as my y and my 1/2. The only thing that changes in this quadrant is what? The signs. What's negative over here, x or y? On the left. Quadrant 2. What's the x, right? That would be my negative 1/2. That's the only thing that changes. Okay, this point here that I drew is still going to be root 2 over 2. The x negative. And then this right here would be root 3 over 2, 1/2. So it's the same pattern all the way around for the unit circle. So there's really only like 3 things you got to memorize, right? You just have to memorize root 2 over 2, and then understand how these flip. And then you have the whole unit circle done. Okay, is there any questions on that? Okay. All right, so we already did A and B down here, so let's just answer C real quick. It says, how do the coordinates of the points relate to the measure of the rotation angle? So, x equals cosine theta, y equals sine theta is the relationship. Okay, or you can think about it as xy or cosine sine. When it comes to unit circle, that's kind of how you want to think about your coordinates. Okay. All right, so then your next page, you have the complete unit circle for your viewing pleasure. Okay, and so you kind of see what I was talking about. Okay, I'll just kind of talk through it real quick here. But so again, this triangle here has a bigger width than it does height. So the width is the big number, which is root 3 over 2, the small number 1/2. The pattern continues all the way around. The only thing that changes is the signs. Okay, and that's going from your 1, 2, 3, 4th quadrants. Okay, or even your cast rule. Okay. Yeah, that's pretty much it. I mean, other examples continue on a little further. We have here, here, and here. Obviously, the width is bigger, so that's why the negative root 3 over 2 is the x, the width. Okay. All right, so just finishing off this here, again, it's just repetitive, but sine theta is x, or excuse me, y. Cosine theta is x. And then star at the bottom there, star that's sine over cosine, this right here, that is tangent, x, which is y over x. All right, now we have a few examples and we all will be done. So we're going through this quite a bit faster than last class. All right. All right, so here we go. So now we're going to be using our unit circle, not our calculator, to figure these out. So use the unit circle to find the exact value of the trigonometric ratios for a rotation angle of 240. Give your answer with a rational denominator, so don't have any radicals on the bottom. Okay, so sine 240. So always the first thing you want to do is you want to figure out what triangle is it, the 60, 30, or 45. Okay, that's the reference angle. So the reference angle of this, okay, if I'm thinking about it, 240 is down here. It's a 60-degree reference angle. So I want sine of 60. Okay, sine of 60, if I'm just thinking without using, I mean, it says you can use unit circle, but without using it, if I try to memorize it here, that would be bigger for taller, so it should be 1/2, or no, yeah, taller, so it should be negative root 3 over 2. Yeah, that's right. You can look at your unit circle like it says too if you want, but we were looking for sine of 240. Look on your unit circle at 240, you'll see negative root 3 over 2. Cosine would be negative 1/2. Then tangent would be these two over each other. So it would be negative root 3 over 2 over negative 1/2. Okay, the negatives cancel and the 2's cancel, so you're left with just root 3. And that makes sense because that's in quadrant 3. Tangent's positive in quadrant 3 by the cast rule. Okay, so use the exact unit circle to get the exact value of cosine 135. Cosine 135 is negative root 2 over 2. That is a reference angle of 45. Tangent of 120, that would be root 3 over 2 over negative 1/2, which would give you a negative root 3. For tangent of 120. Sine of 180, kind of tricky. Sine of 180, that would be over here, one of the anchor points. What's sine right here? 0, good. And tan 270, what do we know about that one? We already did that one. Not 0. Negative 1 over 0, undefined. Good. For tangent, yep. Y over x. All right, I'm going too fast. Slow me down. All right. Here we go. 6 and 7. Okay, so this is a good one. Okay, this is the type of problem I could see on one of your guys' exams in terms of diploma, final type of stuff. It says A is at negative root 2 over 2, and B is at negative 1/2, negative root 3 over 2. Our 2 points on the unit circle. If an object rotates counterclockwise from A to B, what is the angle that is rotated? So if we go ahead and plot these points, negative root 2 over 2 we know is right here centered. That's a 45-degree reference angle because we know anything that's root 2 over 2 is going to be the 45. Then we have negative 1/2. Okay, so with negative 1/2 root 3 over 2, negative root 3 over 2, that's in quadrant 3. So we got to figure out what that reference angle is. Negative 1/2 is the smaller number, so that means that this is going to be the 60 degree because negative 1/2 is smaller. That means there's a bigger, negative root 3 would be the 30. It can only be 60 or 30. That's your options. Okay, so you can see now by going counterclockwise, which is this way, we can add the two reference angles and get 45 plus 60, and you get 105 is how much they rotated. Okay, you also could have done the rotation angle. Like the example, the rotation angle here is, I think, 135. Yeah, and the rotation angle here is 240, and you could have subtracted those two numbers and got 105 as well. I think it's easier to use the reference angles. Okay, so next one. On your calculator. Okay, use a calculator to determine the 4 decimal places of the coordinates to the point 148. So 148 is not one of our common ones. It's not 45, it's not 30 or 60. So we're going to use our calculator. So what it wants us to do is we're going to go cosine of 148 and sine of 148 to get that point. Because remember, it's x, y, right? So we're just going to put those in the calculator and it's going to kick out 2 decimals. That'll be our point. We should expect, so that's cosine of 148, that's in quadrant 2, we should expect that to be negative and that to be positive. And indeed, when you plug that in, you get these two numbers. Hopefully you got this. Negative 0.8480 and 0.5299 would be the two answers there. And just plug it into your calculator. Okay, and this time they kind of give us that weird decimal point like we were just given, or we just got, I mean. Let's determine the value of theta. So we're trying to figure out how far this is. So again, we get an x is negative and a y is positive, so we feel like we're going to be in quadrant 2 again. Okay, so we feel like it's going to be somewhere over here. Now, if I have cosine theta equals negative 0.8829 or sine theta equals 0.4695, how can I solve for theta? How can I solve for theta? We did this thing 2 days ago. How do we get rid of, what's that? Yeah, second cosine, second sine, which inverse, right? We can inverse cos or inverse sine. So to get theta, I can go cosine inverse negative 0.8829, or I can go sine inverse 0.4695. When you do that, your calculator should kick out the reference angle, which your reference angle is 28 degrees. So that means from here to here is 28 degrees, and then we go to complete that and finish and get the reference angle. So the the rotation angle. Okay, so 180 minus 28, so give me 152. 152 degrees would be your rotation angle for that problem. All right, we got one last example here. All right, last one. Okay, use a chart or unit circle to find the exact values of the given. So it's just giving you two things. You have to kind of do a little algebra. So you figure out what's cosine of 300. So you go to your unit circle. Cosine of 300 is 1/2 plus, and sine of 330 is negative 1/2. 1/2 plus negative 1/2, 0. That's all it's asking you to do. When there's a square like that on the sign, that means the whole thing's squared. Okay, what I mean by that is once you get sine of 225, it's that thing squared. So sine of 225 would be negative root 2 over 2. They want that thing squared. Same thing for cosine of 225, which is also negative root 2 over 2, and that's squared. Which gives you 2 over 4 and 2 over 4, which is 1/2 plus 1/2, which is 1. And the final hurrah here. All right, so 2 of tan 150, so tan of 150 is 1/2 over negative root 3 over 2. The 2's cancel, and it gets me, let's see here, did I put that in right? 150, yeah, 1/2, yep. So that's going to give me negative 1 over root 3, which gives me negative root 3 over 3. That's what tan of 150 is. So I can go 2 times negative root 3 over 3 for that piece. 1 minus root 3 over 3 squared is negative, which doesn't matter because we're squaring it. So that's going to give me, for this fraction, that being squared, the root being squared is going to be 3 over 9, because 3 squared, which is 1/3. So the bottom is 1 minus 1/3. There's a lot of fractions here. This is what you end up having. Negative 2 root 3 over 3 over 2/3. Okay, let's point out this right here. I have a 2/3 over a 2/3. One's negative, one's positive. What's something over itself with one negative, one positive? Yeah, just negative 1. So it's just going to be negative root 3. The 2/3 essentially is canceled with a negative. Okay. All right. What kind of fast? Did I lose somebody on the fraction stuff? Are you guys sure? All right, let's stop this here.